Okay, so what we're looking at is we've got this function here that it was 1 plus x divided by 1 minus x. Where is that function? What values of x would make it less than 0? And because of the fact that it's a fraction, we had to consider all the possible options for where it would be less than 0. So that would be when a fraction is negative, all right? So we over here we talked about, well, how can what are all the possible options where a fraction could be negative? And we said, well, that's true when the numerator can be positive, so therefore greater than 0, and the denominator has to be negative in that case. So then you get a negative fraction. But based on what you know about it, the numerator can also be negative and the denominator can be positive. What can't be the case is both positive or both negative. Because if both are negative, the fraction is actually greater than 0. It's a positive. The other one to consider is if the numerator is equal to 0, what do you get? 0, right? And why were we not going to consider this one, Aidan? Yeah, exactly. We want it where it's less than 0, not equal to 0. So if there was an equal to 0, so we've got these ones here where they've got and equal to, all right, you have to consider it, all right? So we went through and we looked at it and said, right, here's the a and the b, the fraction. So either 1 plus x is greater than 0, 1 minus x has to be less than 0. So that's the positive negative version. And we came up with two solutions where x is either greater than negative 1 or x is greater than 1. Right? So one of those supersedes the other. So we were saying that x greater than 1 has to be the more powerful one, the overriding one, because if I make it x is 0, that applies for this one, but it fails this one. All right? So we thought this was the one that we had to take account of, x being greater than 1. All right? And then when we did the other side, being the top being negative and the bottom being positive, we got the same sort of thing, but the sign's the other way round. Okay? And we thought this one, x being less than negative 1, this is the one that we had to take into account, yeah? So I then said that the final stage was, well, is it just that and that to finish us off? I don't think I wrote that down. So just those two. So then it said check graphically. So if we do check graphically, all right, let's put in y equals, what is it? 1 plus x, 1 minus x, okay? So that's what the graph will look like. So it's the same kind of thing as a reciprocal function, all right? So just to make it clear, let's zoom in. I'm going to put a line. We wanted where it's less than 0, so I'm going to put y equals 0 in just as a line. All right, it's the blue line, it's the axis. All right, so we now want, where is that line, this function, less than 0? Well, that means it's under the blue line. All right, so if I take a quick screenshot, and then I can write over it as well. Work there, does it? But never mind. Let's add it here. So let's see whether that confirms what we were saying or not. All right. So, sorry for the extra screenshot in there. So where is it under the line? So we are looking for, from this point here, what do we think that point is? Negative 1. So we would say probably x has to be less than negative 1. That gives me the line under the blue line. Make sense? And then, well, it's always under the line, but we can't see where it starts. So how do we know where it starts? Yeah. It does, doesn't it? So remember, we've got this asymptote here at this line, right? That asymptote is at x equals 1, which means the line is under this all the time x is greater than 1. Okay? And this one, this asymptote comes from the fact that the denominator is not allowed to equal 0, right? It kind of confirms that. You see that? X can't equal 1 because that would make the... So that's also part of it. So have we considered everything? There's nothing else to consider, right? So we think x less than -1, x greater than 1. Is that what we confirmed using our thing? So we said x greater than 1, x less than -1. All right? Can I write it with 1x like this? So do I write 1 and -1? What do you think? It's not, because it's not in between, right? It's not about brackets, right? The regions we want, we're allowed to use all these x values here going in that direction, and we're allowed to use all these x values going in that direction. So because it's not a linked area, all right, we shouldn't write it with one value of x like this. Just looks awkward, doesn't it, with the positive and the negative. So we will keep them as two separate inequalities there. All right, make sense? Right, so now I guess the question is, we've got, that's this first one done. All right, we've got others to do. Would you like me to go through one more with you? Now we've kind of got the process going, yeah? Or, yeah? Okay, let's do this one then. B, that gives us an extra little thing to do, which is good. All right. All right. So, what do you think? Sorry, I'm sat there. This has to be plugged in. What do you think is the first step we need to do then? Well, if it's easier, always think, right, what's this got to be? 0. So how do we get that to start with? Minusing 2. So we've got x plus 6 divided by x plus 1 minus 2 needs to be greater than or equal to 0. What about this, guys? What do I need to do with that? Or do I not need to do anything with it? Or what is it?
It's just saying value of x can't be -1.
Why not?
Because if it was, then the bottom, the denominator would be
Exactly. Does it need to be there?
No.
Why, yes. Technically, it should always be written when you've got a value that you know you can't use in a function. Right? If you write a function, you should state what values it's allowed to be used for, yeah? Right? So, for instance, if this function only works for integers, you have to write x can only be an integer, yeah? If it can only be positive numbers, you have to write x can only be positive. So we are communicating the fact that x is not allowed to be -1, right? So you might say that's a bit of a kind of, it doesn't affect me in anything I do. Yes, we don't need to use it, but it might help us, eh? Well, in fact, it does help us, doesn't it? All right, it tells me where one of the asymptotes is already. Right? But mathematically, we don't need to include it in any of our calculations as such. We use it as information. All right. So remember, when we've got a fraction, we want it to be greater than 0. Let's go through our options. So we've got positive A, positive B, negative A, positive B, positive A, negative B, or negative A, negative B. Which ones do I need to consider for this? Positive, positive, and negative, negative. We all happy with Y? Yeah? Sure? Everyone's happy with that? Because it's got to be greater than 0. All right, so we take the ones that would be positive. So we need, then, for this one, we would want x plus 6 so it's greater than or equal to 2, actually, isn't it? So did we need to do the subtract 2 bit, I wonder? And then we want x plus 1 has to be greater than or equal to
-1.
What do we think? 2 again. Should we try it? 2 again? Think 2? Okay, so what do we end up with then? We then x for this one must be greater than or equal to -4. And for the second one, we want x must be greater than or equal to +1. Okay? So we would choose this one. All right. By the way, I'm not saying all this is correct. So when you write your notes, be aware that you may have to go through and add notes and so. But what's good is you can add notes and go, oh, this is an assumption I made that might not be correct. Yeah. So just be prepared for that. Those of you that like immaculate notes, I'm looking at 3 in particular. All right. But don't rub it all out, because this is a thought process we're going through, and I'm not saying it's wrong, but if it is wrong, it'd be good to think, why was it wrong? Add that to your notes, right? So that's this one dealt with. What about this one then? So we would actually want x plus 6 is less than or equal to because I actually want this whole thing to be greater than 0. All right. What do we think? 2 again, greater than. What do you think?
The x plus 1 would be
Think this one should be less than 0.
Negative, but then it also needs to be at least 2 negative a divided by negative 3 needs to be at least 1.
Yeah. So what are we going to do?
instead of 2 for x plus 1, wouldn't it be -1? Since if it's the denominator and x can't.
Which one are you on? Are you here?
No, I'm
Here?
where it says x plus 1 is greater than or equal to 2.
Yeah.
I'm just saying, would the 2 be negative? Instead
Well,
of 2, it would be
we've
-1.
looked at this one here, haven't we?
Yeah.
So if I subtract 1, I end up with 2 subtract 1 is 1. So x plus 6 is less than 0. What are you saying?
It's not when we add minus 2 to the actual fraction to minus 2 over 1.
Say it again.
Could we add the negative 2 to the actual fraction to make it easier? So we have
Oh, yeah.
x plus 6 minus 2.
Ah.
Yeah.
So just x plus 4.
So we're struggling at this point, aren't we? Because of this bit that's not the fraction, yeah?
So we couldn't put it over 1.
Yeah, so we need to sort that out.
So negative 2 over 1.
So should I get rid of all of this now?
Yeah.
Who was really struggling to think, like, solve the problem mentally with like a fraction, but then there's the 2 there, and if this has got to be positive, but then we've got them struggling, right? That gives you a clue that we're kind of in the wrong ballpark. Okay? So we've got to make, when we deal with fractions, we should deal with one fraction, not parts. So let's combine this with this. Let's actually do the subtraction. So what should we convert the 2 into? It's not going to be 2 over 1.
4 over 2.
How do you subtract fractions? Common denominator.
Then it would be
Minus 2 over x plus 1.
You can't just do that.
X over x plus 1. So then we say
2x plus 2 over x plus
Well, let's just do x plus 1 and x plus 1 first, yeah? Are you okay with, if you multiply top and bottom by the same thing, you actually keep the same thing, don't you?
Yeah.
This here is still 2. And that's all important, all right? We can't change its value to something else.
How did we get to that one where in the one on the right, the 2 times x?
Well, that's what I was just saying. This is 2, but I need it to have x plus 1 as a denominator. So if x plus 1 needs to be the denominator, I must also multiply. Because if you want to think of it as 2 over 1, one lot of x plus 1 is x plus 1, but you've also got to multiply the top as well.
Oh,
Otherwise, you change its value, don't you? Like, back to basics, 2/3, if I multiply the bottom by 2, I get 2/6. Is that still the same thing?
no.
No, but if I also multiply the top, I get 4/6, which is the same thing. Now, that's kind of the reverse that people have done in the past, where they say, oh, well, 2/3 multiplied by 2 is 4/6, because they do top and bottom. And then that doesn't multiply it by 2, does it? You don't get twice as much as you had. You have exactly the same. So it's kind of the opposite way of thinking, in that if you want to combine fractions, you can multiply the top and bottom by the same thing. And that same thing can be as complex as you like, as long as it's the same on the top and the bottom, numerator and denominator. So now we can combine them, can't we? So we've got x plus 6 subtract 2x plus 2. Why have I put brackets?
Oh, because we're minusing it, so it's minus 2x.
Yeah, I always say if there's a subtraction in there, especially with, when you've got algebra, double your thinking. Like, take a moment to think about that and just check you're doing the right thing. You must subtract the whole thing, not just the 2 bit. I must subtract the whole thing, right? So that then gives me what? Well, then that's x plus 6, subtract 2x, but now subtract 2, not add 2. That's where the common mistake is, yeah? So you could highlight that yourselves, right? That's where the common mistake would be. And if you write what's the common mistake and you read your notes, you won't make the mistake. Hopefully, that's the plan. All of that divided by x plus 1. Okay. So then we can simplify that. Remember to keep that in there, guys, because sometimes if I don't, I've seen it with students, if they forget to keep writing that, then when they get to the end, they forget it was even there. and don't actually answer the question. So what do we end up with? X subtract 2x is minus x, plus 6 subtract 2 is plus 4, right? So I'm actually going to write that, if you don't mind, as 4 minus x. You okay with that? Just keeping it neat and tidy. Over x plus 1 now is greater. Look at that now. That's much nicer, isn't it? Much, much nicer. So now we are looking at the A, B both being positive and A negative, B negative. Now we can do that. No problems, can't we?
Mr. Potts, the one on top was the common mistake.
This bit where people, if you subtract, what people would do is just write x plus 6 subtract 2x plus 2. If they haven't put brackets, that's what would happen. So you'd end up with, instead of 4 minus x, you'd end up with 8 minus x.
So technically it's a
Which-
negative 1 outside the brackets, not the minus. Because if you're becoming the negative part 2 times the x,
Yes, you could do it like that, yeah. Think of it like that as well, yeah.
that's what I wrote.
You can put negative 1 and expand the brackets. Fine, all right? Mistake is this would be a plus 2, not a negative 2, yeah? So we write this, so you would have 8 minus x as the mistake.
So was that
And obviously that affects all your solutions, doesn't it?
So is the 4 minus x over x plus 1 our final solution, or do we still?
No, we've got to find what the x values need to be now. What x values do I use to make this greater than 0?
1.
So now I've got these two options that I identified earlier. So we've got, for this positives, we've got 4 minus x has to be greater than or equal to 0, which means that, okay, and we've got x plus 1 needs to be greater than or equal to 0, which means x is greater than or equal to,
1. I mean, negative 1, sorry.
good, negative 1. And which one do we use?
4. Because it says x can't equal negative 1, and for 4, it said
Look at them carefully. X must be greater than 4, and x must be, no, sorry, x must be less than 4, which is, makes sense. X must be greater than negative 1.
oh, because that one gives us.
That's all right at the moment, isn't it? They're all right, right? Both of those could be fine. So let's check with the other one. Let's see how that affects things. So we've got 4 minus x must be less than or equal to 0, which means that 4 must be less than or equal to x. Okay. And then we've got x plus 1 must be less than or equal to 0, because it needs to be negative, which means that x must be less than or equal to negative 1. Okay.
But actually, wait. But if we do, if we put negative 1 in the denominator as x, wouldn't it be 0? And if we, if we try something with 1, sorry.
All right, so how do we interpret these 4 things? Because we've got x must be greater than 4, and x must be, no, sorry, x must be less than 4, x must be greater than 4.
And there's the 2 directions. We have to look at.
But this is around the same point, and equal, so that means you can have everything.
So anything greater than
So
4 and then
here's my, if this is my x-axis, yeah, I'm looking at 4, positive 4, and saying I'm allowed
anything
Everything. And then we're looking at -1 and saying greater than -1. All right.
So any number.
So anything should work.
Except we know that -1 doesn't work.
Okay.
Because,
So if we could run,
well, wait,
so it's greater than, less than
5
equal
over 0 is 0, right? Is 5 over 0 0?
0, 0.
So we know it can't be the and equal to -1, don't we? All right. So
Or is it
what?
because we have and equal when you only should just be worrying about it
Well,
being
I tell you what.
positive or negative
Let's okay.
instead of
Let's look at a sketch. What do we think? We've got these two numbers to add into a sketch. What do we think we should do? All right. We know what? That x is not allowed to equal.
-1.
Okay. So if I put a dotted line there, that's my asymptote. All right. X equals -1. I'm also going to put a dotted line where x equals 4. Not saying that's an asymptote, but that's an important point, right? So, is there anything else we can know?
That it's less than.
Let's go
or equal
back
to
to the very beginning, right? What can this fraction, okay, is there any value that that fraction can never be? Is there a y value that can never happen? Well, it can be 0 actually, because if x on the top was -6, that would give me a y value of 0, wouldn't it?
Yeah.
So that's the difference between this one and just a reciprocal function where it's a number on the top. These fractions can equal 0.
-7 because if the fraction on top, if it was -2 then plus 6.
So is there any value that this will never be? But that's what x can't be. Y can be it. Y could be -1. Is there any value that y can't be? So what that means is there any value we can put in here, but the y value will never be that? It's actually, like, when you think about it, it's actually relatively simple to think about it. That fraction, if I tell you the answer, you can tell me why. That fraction will never equal 1. Why?
Because it's +6.
And why is that the reason?
Oh, it's -2, actually.
That's not part of the fraction. That's something we have to consider afterwards. But just the fraction bit will never equal 1. Why?
because you would
Because there's a +6 and a +1 is actually the same value, so you can, nothing adds to 6 and 1 that would make the same
Good.
Yeah.
How do you make 1 with a fraction, a division? The two numbers must be the same, right?
Yeah.
So I look at that and go, well, x and x, to make it equal 1, it would have to be x divided by x, right? But on the numerator, I've added 6, and on the denominator, I've added 1. They will never be the same number, right? Now, that leads me to the next thing, but if this cannot equal 1, what can y not ever equal in this case? -1. 1 minus 2 would be -1. All right? So, we go back to this that we're looking at. This will never be able to be -1.
41. Oh, wait. No.
And that's the y value can never be -1. All right? We've already said the x can't be -1. We've now decided the y value can't be -1. Does that make sense? Could I have figured that out from this bit?
No.
Well, I could actually. If I'd have written this way round, -x plus 4 divided by x plus 1, if I just look at that bit,
Oh, it's
right? Again, those two would have to be the same for it to be -1, right? But it's never going to be because of the plus 4 and plus 1, all right? So I could have got it straight from this one, actually, but slightly harder to understand. That's why I went back to the other. So actually, we can now put another line, okay, an asymptote line at y is equal to -1.
And another thing that we could notice that it wouldn't be the same is because it's a negative over a positive. So if say x was
But that's
3,
not the one
it
we're...
would be -3 and 3, so that way they wouldn't be the same.
Don't get what you mean.
So like up at the fraction up there where it's -x over x, where we shift it around.
Yeah,
Could like say if we had x is 3 maybe,
yeah.
would it be -3 over?
But it's plus 4 as well. It's not just -x and x. I've just highlighted that bit.
But could we also use that to tell if it was an asymptote?
But 3 is not an asymptote. You can make this equal to 3. It'd just be different numbers, yeah? -3. You can make it equal 3. You can make it will work. The only one that will not be ever is -1. All right? I can tell because of the type of function it is. I know the shape. Now, here we go. So based on the shapes of these functions, we know the shape of the curve. We've actually got our two asymptotes here. All right? What does it look like? Jack?
Would be a curve going up.
So this is the asymptote. Do we come down or do we go up?
Come down.
Come
It
down?
would go up on this, yeah, toward that way.
Have a look. Why don't you put this into your Desmos? Why don't you do that now? Just so I get you doing something rather than some of you are starting to switch off with it.